Alright everybody, welcome to the video for unit number 2's test review. So on tomorrow's test there's a couple main topics if you think about it. You have to be able to solve an equation with rational expressions, you have to be able to solve an equation with radicals, and you have to understand what undefined values are. Those are the three kind of main concepts here. Right. I'm going to go through all the questions here. If you need to rewind or pause or anything like that, you can totally do that. The other thing I would suggest is don't just use this one video or this one worksheet to review. I would definitely look back at everything that we've done so far this quarter in the process of reviewing for this test. So let's take a look at number 1. So for number 1, I see rational expressions. So I can make this, let's see, we'll use blue today. So we'll make this x plus 3, x minus 3. That's kind of thick. Let's make that smaller. All right. And I then have to make all the denominators that same denominator. So this one's missing the x plus 3. So I'll put it there and there. I think we even did this one in class. The 1 is really just going to become x plus 3, x minus 3 on top of itself. So we'll get that. Because 1 is really anything divided by itself, so if I need to make the common denominator, I can just make the numerator whatever I want to make the denominator. That kind of makes sense. I'll even do some distributing there. Alright, so once I have that, I then have to go through and make a equation. So I'm going to make an equation with everything that's left up top here. So I'm going to get 30 plus, now x plus 3, x minus 3, I already know what that multiplies out to be because I did it up here. And that's all equal to 5x plus 15. If I get everything to the same side of the equation, so if I move the 5x and the 15 and reorder everything, I get x squared minus 5x plus 6 equals 0. I know I'm skipping steps there, but at this point you should be able to solve the equation for 0. If we then factor, we're going to get x minus 3, x minus 2, both equal 0. So my two answers are 3 and 2. Now, choice A looks like it's the right answer, but we have to remember, for every one of these we have to check our answers. If you check 3, 3 does not work. 3 is what we call an extraneous solution, which is why choice B is the answer. For number 2, I see a radical. So the first thing I want to do here is square both sides. Remember, when I'm squaring x plus 1, I can use my tabular method. And that'll give me x squared plus 7 equals x squared plus 2x plus 1. Now, general rule here in algebra is if I see the same term on both sides of the equation, they cancel. So if I subtract 1, I get 6 equals 2x, divide by 2, and I get x equals 3. Check it, it works, so we're all good. For number 3, I think we even talked about this one in class. Since it's multiple choice, I would never solve this algebraically. I would just do this graphically. So if I did this graphically, I'm going to have a graph that looks like this and another one that looks like this. All I'm doing here is looking for the one point of intersection on my calculator, which becomes 5. To get the point of intersection, you're going to hit second trace and then go to the intersect button and hit enter 3 times. You could also use that to check an answer like number 2. Number 4, since it is algebra, I need to subtract 1 on both sides. So I have the square root of 3x plus 1 equals x minus 1. I'm going to square both sides, so I have 3x plus 1 equals x minus 1 squared. I've already done x minus 1 squared once already in this video, so I already know the answer is going to be that. If you multiply it out on your own, no, you'll get the same answer. Move your terms to the other side, so subtract the 3x and subtract the 1. And we get 0 equals x squared minus 5x, which is factorable. I can factor out x, which leaves me with x minus 5. giving me two answers of 0 and 5. I have to check both of them. If I plug in 0, I'm going to get the square root of 1 plus 1 equals 0, which does not check. 5 does check, so we're all good. Number 5 says the expression that 5 over x minus 2 plus 3x is meaningless when x is equal to what? Meaningless is just another way of saying undefined. So undefined values here are going to be 2 and negative 3. Six, again, an undefined question, so I got to factor my denominator, figure those values out. So I have x plus 3x minus 3, which tells us that x of 3 and negative 3 make this undefined. 7, another undefined question, so I have x plus 5, x plus 2. So my undefined values are x cannot be negative 5 or negative 2, so I'm looking for those as choices. Negative 5 is a choice. Simplest form tells us to factor first. As soon as I see that, that's what I'm thinking. So if I factor everything, I get 2 times 2x minus 5. I get x minus 5, x plus 3. If factoring is your issue, please come and see me. We're going to do it for the rest of the school year. The x minus 5's cancel, so I'm left with 2 over x plus 3. And remember, from way back in lesson 1, we have to also show the undefined values. So x cannot be negative 3 or 5. Simplest form again, so we want to factor x minus 2, x plus 1, x minus 2, x plus 1, plus 2, sorry. Minus 2's cancel, so I'm left with x plus 1 over x plus 2. Number 10 is kind of a tricky question. It's still factoring. The numerator is unfactorable. There's nothing to do there. The denominator becomes x plus y, x minus y. Now, it looks like at first glance nothing reduces, but the minus reduces. It just reduces to negative 1. So we get an answer there of choice D. We did something like that in class. We used numbers, and then I showed you it also works with variables, right? Because whenever we have subtraction, because of the non-commutative property of subtraction, it's not going to reduce to 1. It's only going to reduce to negative 1. Oh, it's the only one there. All right. Let's look at 11. So 11 is kind of tough. My common denominator is going to be p minus 5, p plus 3. So the first fraction is going to get multiplied by p plus 3. So I'm going to get 3p times p plus 3. That'll allow my denominators to be the same. Minus 2. That second fraction needs the p minus 5, so I'll multiply that. And the last fraction also needs the p minus 5. Notice I'm doing all this in one step because really we can. We know that the denominators are going to cross off. So I'm essentially just multiplying anything to each numerator that I know I'm going to have to make the denominator for. If I do some distributing, I get 3p squared plus 9p minus 2p plus 10 equals p squared minus 5p. The sign is important. Remember, you're distributing the negative 2. Try and get everything to the same side. So I'll move the p squared and the 5p. So this becomes 2p squared, 9, negative 2, and 5. What does that give me? 12 plus 10. I notice everything there is divisible by 2. So I get p squared plus 6p plus 5 equals 0. So I get p plus 5, p plus 1. So my answers are p equals negative 5 and p equals negative 1. Check to see if either of those make undefined values. They don't. So both of those are, in fact, your solution. the last one, you have to figure out something to multiply so that the variables all cancel out. I'm going to start by trying to get rid of the x's. So if I multiply the first and last equations together, I get x plus y plus z equals 1. Negative x plus 3y minus 5z equals 11. So that's going to give me 4y minus 4z equals 12. I haven't used the second equation yet, so I'll multiply that, or write that out actually. And then from here you can do one of two things. I noticed that everything there is divisible by 2, so I can just divide the whole equation by 2. Or I can multiply this last equation by 2, which is how I'll do it, because that's how I'm sure some of you will do this. The reason why I'm choosing the last one is so that, again, those x's will cancel. So I'm left with negative 2y minus 4z equals 24. Then I want to stack those two together. Right now, if I was to add these, nothing would cancel. So if I rewrite it, and the place I think a lot of you are making mistakes is you're trying not to rewrite, you're trying to just kind of fudge it. By multiplying the second equation here by negative 1, that allows the z's to cancel. So I'm left with 6y equals negative 12, or y equals negative 2. Once I know y is equal to negative 2, I could say 4 times negative 2 minus 4z equals 12. Solve for z. So that's going to become negative 4z equals, what will that be, 20. So z equals negative 5. Then once I know that, I can find the x value by saying x plus negative 2 plus negative 5 equals 1. So then this is x minus 7 equals 1, or x equals 8. Last thing I can do, I can check by making an augmented matrix and putting that all in my calculator. So the matrix that you'd plug in the calculator would be 1, 1, 1, 1. It would be 2, 4, 6, 2. It would be negative 1, 3, negative 5, and 11. And remember, in your calculator, you're going to do RREF of matrix A. And if you do that, you should get the same answer I got. I'm even going to check mine just to make sure that I got it right. So if I plug it into my calculator, I'd show this on the screen, but it's not working right now, so I apologize for that. There is a video that I posted earlier in this chapter that shows step-by-step how to do all of this. So if you have to, you could always look back at that. That's the nice thing about Google Classroom. It's all there. And I look at that, I figured out that I did actually make a mistake here, so let's go back for a second. So the y value is actually a positive 2, so I have a sign wrong here somewhere. So it looks like the 4y, negative 4y, and 12, that looks right. And then this was a negative 2, so I should have just multiplied this by 2. What the heck did I do there? I multiplied it by negative 1, but I never changed my sign on. It's kind of weird. Negative 4. Here we go. So let's do it this way. So this is going to wind up coming out to be a positive by making this a negative. So if I make these both negatives, then it'll work. That doesn't work there. So this will become 2y minus 4z equals 24. That's right, because that's negative 2, negative 4, and positive 24. So if I multiply this by a All right, so I finally found my mistake. Sometimes that can happen. I had this as a -6. It should have been a +6, which makes this 10, which makes this 10y, and it makes this -10y, making this -6y, thus making the y value +2 instead of -2, which totally can happen sometimes. So then when I do that and solve with a +2 instead of a -2, I see that my z value actually comes out to be -1. And then when I have the correct z and y value here, we see that the y value is 2 and the z value is -1. That gives me an x value of 0. So then checking this actually helped me tremendously because I saw my answers and I was able to track back to find my mistake. So kind of a happy mistake there. Hopefully this video helps. Sorry about all my rambling here for this last question. And hopefully you're studying, reviewing, and looking at all of your notes before tomorrow's test on Unit 2. Have a great night.